Hello there, welcome to the Science Owl Station channel. Today, we invite you to step outside with us into the cool stillness of a night unspoiled by the city's glow. Imagine yourself standing in a quiet field, the grass soft and damp beneath your feet, the air carrying the faint scent of earth and distant rain. Above you, the sky unfolds like an endless tapestry of velvet, scattered with tiny pinpricks of light. Some flicker gently, as if breathing. Others remain steady, ancient watchers over a world that sleeps. For a moment, let yourself feel what humans have felt for thousands of nights before this one. A quiet awe, a sense of something vast and unknowable pressing gently against the edges of your understanding. We stand on this small planet, our feet rooted in soil, our eyes reaching upward, and we cannot help but wonder, what is this immense darkness in which these diamonds float? How far does it stretch? And perhaps the most humbling question of all, where exactly are we within this grand, silent expanse? Before we begin this journey together, we would love to know where you are joining us from tonight. Perhaps you are lying in bed, the blankets pulled up to your chin, in a small apartment in a bustling city, the sounds of traffic muffled by your window. Or maybe you are in a quiet house surrounded by countryside, the only noise the occasional hoot of an owl. Wherever you are, whatever time the clock shows, take a slow breath in, and as you exhale, let the world around you begin to soften. Wherever you are, let the world slow down for a while. Soften your gaze, let the hum of life around you fade, and gently drift with us into tonight's quiet exploration. To ask about the size of the universe is, in a way, to ask about our own significance. We begin not with telescopes or complex mathematics, but with a feeling. It is a feeling that often visits us in moments of stillness. Standing on a beach at dusk, watching the waves retreat into an infinite horizon, or lying on a rooftop, tracing the familiar patterns of constellations with a fingertip. In those moments, we sense that the world we inhabit, the world of daily routines, of worries and joys, of walls and roads, is not the whole story. There is something larger pressing in, something that makes our triumphs and tragedies seem, for a brief second, like the faint outlines of a dream. And yet, this feeling of smallness is not a sadness. It is, if we allow it, a kind of release. To know that we are tiny is to know that we are not required to carry the weight of everything. The universe was turning long before we arrived, and it will continue to turn long after we are gone. In that realization, there is a strange and gentle peace. So tonight, we will not try to conquer the universe with facts, nor will we attempt to hold it in our minds like a globe we can spin. Instead, we will wander through its scales and distances the way one might wander through a vast, silent cathedral. Slowly, respectfully, allowing each new dimension to settle upon us like dust motes in a beam of light. We will begin where all human journeys must begin. Here, on this pale blue that we call home. And from there, step by step, we will let the numbers and the light years carry us outward until the very concept of home expands beyond anything our ancient ancestors could have dreamed. Think for a moment about how we usually measure things. A meter, a kilometer, a mile, these are human inventions, scaled to human bodies and human journeys. We know how long it takes to walk to the corner store, to drive to a neighboring town, to fly across an ocean. These distances live in our muscles and in our memories. But the moment we lift our eyes to the night sky, these familiar measures begin to fail us. The moon, which looks no larger than a coin held at arm's length, is actually a world of rock and silence, orbiting us at a distance that would take months to cross in a spaceship. The stars, which seem fixed to a great dome rotating slowly overhead, are in truth suns like our own, scattered so far apart that the spaces between them dwarf everything our minds can comfortably hold. We are about to embark on a journey that will ask us to abandon our usual scales and adopt new ones. Scales that have nothing to do with footsteps or wheel rotations, but with the speed of light itself. It is a journey that will take us from the familiar ground beneath our feet to the very edge of what can be seen, and perhaps beyond. And the most remarkable thing about this journey is that it is not a journey through space alone. Because light takes time to travel, the farther we look, the deeper we look into the past. When we gaze at the stars, we are not seeing them as they are now, but as they were when their light began its long, lonely voyage toward us. In a very real sense, the universe is a vast museum of its own history, and we are visitors walking through its galleries, surrounded by ghosts of light. But let us not rush ahead. For now, let us remain here, in this quiet field, with the night air cool on our skin and the stars beginning to emerge as our eyes adjust to the dark. Let us take one more slow breath together. Feel the gentle rise and fall of your chest, the weight of your body supported by the earth. Above you, the sky is deepening from indigo to black, and the first true stars of the night are appearing. Not the brightest planets, but the steady, ancient lights that have guided travelers and inspired poets for millennia. In the next section, we will take our first small step away from this familiar ground. We will look at our own planet, not as a place to live, but as an object in space, a sphere of rock and water, drifting in the immense dark. And we will begin to understand, for the first time, just how small that sphere really is. But do not worry. This is not a story about insignificance. It is a story about connection. Because the more we understand our place in the universe, the more we realize that we are not separate from it. We are made of the same elements that were forged in the hearts of long-dead stars. We are, each of us, a way for the universe to know itself. So rest your head gently on your pillow, or let your gaze soften toward the darkness outside your window. The journey is long, and there is no hurry. We have all night. Let us begin our journey by looking down, not up, beneath your feet. Whether you are lying in bed, curled on a sofa, or sitting by a window watching the night deepen, there is ground. Solid, dependable, familiar ground. It is so easy to take this ground for granted, to think of it as the fixed and stable platform upon which the drama of human life unfolds. But this ground is not fixed. It is the surface of a sphere, a great ball of rock and iron and silicon, spinning silently through the void at speeds we rarely stop to feel. Right now, even as you lie still, the ground beneath you is carrying you eastward at something like 1,670 kilometers per hour, the speed of Earth's rotation. And that is only the beginning. At this very moment, our entire planet is also racing around the sun at nearly 107,000 kilometers per hour, tracing an orbit so vast that its diameter stretches more than 300 million kilometers. You cannot feel this motion, of course. There is no rush of wind, no sense of speed. But it is happening, has been happening for billions of years, and will continue long after every human story has faded into memory. Now, Let us try to see our planet not as a place to live, but as an object in space. Imagine floating above it, perhaps at the altitude of the International Space Station, some 400 kilometers up. From there, the curvature of the Earth becomes visible, a gentle arc against the absolute black of space. You would see the blue of the oceans, the white swirl of clouds, the brown and green of continents. It is beautiful, achingly beautiful, but it is also, from that height, already beginning to seem small. Now, let us pull back further. Imagine a view from the moon, nearly 400,000 kilometers away. From there, Earth is a blue marble, about the size of a fist held at arm's length, hanging in a void so dark and empty it defies description. You could cover it with your thumb. All of human history, every civilization, every war, every love story, every piece of music ever composed. All of it has unfolded on that small blue circle. And yet, even this view, humbling as it is only the very first step in our journey outward. To truly understand the scale we are dealing with, we need to place Earth alongside its neighbors in the solar system. Think of the planets as a family, but a family with wildly different members. There are the small, rocky worlds, Mercury, Venus, Earth, Mars, huddled relatively close to the Sun. And then there are the giants, the great gaseous behemoths that dominate the outer reaches. Jupiter, Saturn, Uranus, Neptune. Jupiter, in particular, is a world that challenges our sense of proportion. It is so large that its famous Great Red Spot, a storm that has raged for centuries, could swallow Earth whole with room to spare. But that is just a storm. Consider the planet itself. Jupiter's diameter is about 11 times that of Earth. That might not sound like an overwhelming difference until you remember that volume scales with the cube of diameter. The numbers, when you finally do the math, are staggering. Jupiter is so vast that you could fit approximately 1,300 planets the size of Earth inside it. Picture that for a moment. Picture our world, with its mountains and oceans, its cities and forests, multiplied 1,300 times, all crammed into the swirling clouds of a single world. And yet, even Jupiter, for all its immensity, is still dwarfed by what lies further on. But we are getting ahead of ourselves. Before we leave our planetary neighborhood entirely, there is another perspective worth holding on to. It comes from the space between worlds. Think about the distance from Earth to its nearest celestial companion, the Moon. That distance, roughly 384,400 kilometers, is not just a number to be memorized. It is a gap that can be filled with imagination. If you were to line up all the other planets in the solar system side by side, Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune, they would stretch across space, a string of worlds of various sizes. And here is the astonishing thing. That entire string, all 7 planets laid end to end, would fit comfortably in the space between Earth and the Moon. There would even be room left over. This simple thought experiment, which astronomers sometimes use to help students grasp the emptiness of space, reveals something profound. The distances between celestial bodies are so great that even the largest of them become mere specks in the void. Our Moon, which looks so close in the night sky that we can almost imagine reaching out and touching it, is in fact separated from us by a gulf that could swallow worlds. Standing on Earth, looking up at the Moon, it is natural to feel that we are at the center of things. The sky seems to revolve around us. The sun rises and sets according to our needs. But this is an illusion, a trick of perspective rooted in our embodied experience. As we begin to pull back, as we begin to see Earth as just one planet among many, as just a rocky sphere orbiting a star, the illusion begins to dissolve. And what replaces it is not despair, but wonder. Because if Earth is small, if it is just one of countless worlds, then the universe must be unimaginably vast. And if it is that vast, then the possibilities it contains are beyond anything we can currently conceive. So let us rest here for a moment, floating in the space between Earth and Moon, surrounded by the silent black. Let the thought settle. We live on a planet that could fit inside Jupiter 1,300 times. And Jupiter is only the beginning. There is so much more to see, so much more space to cross. But there is no rush. The night is long, and the universe is patient. Let us turn our attention now to the silent companion that has accompanied our planet for over 4 billion years. If you are near a window tonight, or if you have the good fortune to be in a place where the sky is visible, perhaps you can see it. The moon. It might be a thin crescent, a delicate curve of silver low on the horizon, or it might be full and luminous, casting pale shadows across the ground. For all of human history, this glowing orb has inspired myths and legends, guided travelers across oceans, and stirred the hearts of lovers and poets. The ancient Greeks saw in it the face of Selene, driving her chariot across the night sky. In Hindu mythology, it is the vessel that carries the nectar of immortality. And in the quiet moments of our own lives, it is simply there, a constant presence, changing its shape night by night, but never abandoning us. Yet for all its familiarity, the moon is, in truth, a world apart, a realm of silence and extremes, of mountains taller than any on Earth and plains of frozen lava so vast they are called seas, though no water has ever touched them. Let us try to feel the distance that separates us from this nearest of neighbors. The average gap between Earth and Moon is 384,400 kilometers. Numbers this large are easy to say but almost impossible to truly grasp. So let us translate this distance into something more tangible. Imagine boarding a commercial airliner, the kind that takes you across oceans on holidays. If that airliner could fly straight up and onward, leaving the atmosphere behind and continuing toward the moon, the journey would take about 18 days non-stop at cruising speed. 18 days of watching the Earth shrink behind you, turning from a landscape into a continent, then into a blue marble, then finally into a distant star. 18 days of crossing a gulf so empty that there is nothing to see but the slow crawl of the moon growing larger ahead. By the time you arrived, you would have traveled a distance greater than the circumference of Earth 10 times over. And yet, in cosmic terms, you would have barely stepped out your front door. Now, let us try another thought experiment, one that brings this distance into even sharper focus. We mentioned earlier that all the other planets in our solar system could be lined up between Earth and the Moon, but let us take a moment to really imagine that. Picture Mercury first, a scorched, cratered world barely larger than our own moon, placed in the void. Next to it, place Venus, shrouded in thick clouds of sulfuric acid, its surface hot enough to melt lead. Then Mars, the red planet, with its dormant volcanoes and ancient riverbeds. Now comes Jupiter, the giant, its bands of orange and white swirling in eternal storms. Beyond Jupiter, place Saturn with its glorious rings, so wide they would stretch nearly from Earth to the moon themselves. Then Uranus, pale blue and featureless, rolling on its side like a cosmic sleeper. Finally, Neptune, the deep blue sentinel of the outer solar system, whipped by the fastest winds in the known universe. All 7 of these worlds, arranged in a line, would fit comfortably in the space between us and our moon. And there would still be room, perhaps 100,000 kilometers of empty space, before you reached the lunar surface. What this image reveals is not just the emptiness of space, but the immense scale of the void in which our cosmic neighborhood floats. The planets themselves, which seem so large when we stand on Earth and look up, are dwarfed by the distances that separate them. And the moon, which dominates our night sky, is in fact a kind of gatekeeper, marking the boundary between the Earth we know and the vast, silent expanses beyond. On the near side of that boundary, there is life, warmth, the sounds of wind and water and human voices. On the far side, there is only the cold and the dark and the slow, patient drift of worlds. Think about the astronauts of the Apollo missions, the only humans who have ever crossed that gulf. As they traveled toward the moon, they looked back and saw Earth rise above the lunar horizon, a blue and white marble hanging in a blackness so absolute it seemed to swallow everything. They described it as fragile, precious, impossibly small against the immensity around it. And when they landed, when they stepped onto the dusty, silent surface of another world, they left behind footprints that will remain undisturbed for millions of years, because there is no wind or water on the moon to erase them. Those footprints are still there, perfectly preserved, along with the flags and the equipment and the tracks of the lunar rovers. They are monuments to human curiosity, resting quietly on a world that has no atmosphere, no sound, no life. From the moon, if you stood on its surface and looked up, you would see the constellations as humans have always seen them, but with one profound difference. Earth would be a constant presence in the sky, never moving, always in the same place. For someone standing on the near side of the moon, Earth never rises or sets. It hangs there, fixed and luminous, a blue beacon in an eternal night. Imagine the loneliness of that view, but also its beauty. Imagine watching our planet slowly rotate, seeing the continents drift past, the swirl of clouds, the glitter of sunlight on oceans. Imagine knowing that everyone you have ever loved, every story you have ever heard, every moment of human history is happening on that small blue circle, and that you are separated from it by 384,400 kilometers of silence. We will leave the moon now, but let its image linger. It is our nearest neighbor, our constant companion, and the first milestone on our journey outward. In the next section, we will turn toward the center of our system, toward the source of all the light and warmth that makes life possible on this small planet we call home. But for now, let yourself rest in the thought that even this familiar silver coin in the sky is a world unto itself, waiting patiently in the dark, keeping its ancient watch over the Earth. Now we must leave the familiar embrace of our planetary home and step into a realm where the very meaning of distance begins to transform. The moon, that silver companion we have just visited, is close enough that we can still measure its distance in kilometers, even if those kilometers number in the hundreds of thousands. But as we turn our gaze toward the sun, the center of our system, the source of all the light and warmth that makes life possible, we find ourselves confronting numbers that begin to strain the imagination. The Sun sits at an average distance of about 150 million kilometers from Earth. This is such a foundational measurement in astronomy that it has its own name, the astronomical unit, or AU. 1 AU is the distance from Earth to the Sun, and it becomes our new yardstick for the spaces within our solar system. To reach the Sun in that imaginary airliner we boarded earlier, flying at cruising speed, you would need not 18 days but nearly 2 decades. 19 years of continuous flight, hurtling through empty space, watching the Sun grow imperceptibly larger ahead, while the Earth shrinks to a pinpoint behind you. And yet, even this immense distance is merely the first tick on a scale that will soon expand beyond all recognition. Let us take a moment to appreciate the Sun itself, for it is the anchor of our system and the reason we exist at all. If you have ever stood outside on a summer afternoon and felt its warmth on your skin, you have experienced the gentle touch of a nuclear furnace so vast and so powerful that it defies easy description. The Sun contains 99.86% of all the mass in the entire solar system. Everything else, all the planets, all the moons, all the asteroids, all the comets, all the dust, makes up less than 1/5 of 1% of what orbits that central fire. Jupiter, which we marveled at for being able to swallow 1,300 Earths, is to the Sun what a grain of sand is to a beach ball. In terms of diameter, the Sun stretches about 1.4 million kilometers across, which is roughly 109 times the diameter of Earth. You could line up 109 Earths side by side across the face of the Sun, and even then, you would not quite reach from one edge to the other. In terms of volume, the numbers become almost meaningless. More than 1 million Earths could fit inside the Sun's fiery sphere, and still there would be empty space between them. Now, with the Sun as our new reference point, let us begin to explore the distances that separate the worlds of our system. Mercury, the innermost planet, orbits at about $0.40 from the Sun. Venus, our sister world, at about $0.70. Earth, by definition, at $1. Mars, the red planet, at about $1.50. So far, the distances are manageable, at least in terms of the astronomical unit. But then we cross the asteroid belt and enter the realm of the giants. Jupiter orbits at about $5.20 from the Sun, more than 5 times farther than Earth. Saturn at $9.50. Uranus at $19. Neptune at $30. And then there is Pluto, the distant dwarf planet, which orbits at an average distance of about $39.50. To stand on Pluto and look back at the Sun is to see not a blazing disk but a bright star, no larger than any other, though far more brilliant. The sunlight that reaches Pluto is about 1,600 times fainter than what we experience on Earth. It is a cold, dim world, forever locked in a twilight that would seem like deepest night to our Earth-accustomed eyes. But even Pluto is not the edge. Far beyond it, stretching out to perhaps as much as 100,000 Australian dollars from the Sun, lies a vast, spherical shell of icy bodies known as the Oort cloud. This is not a dense swarm like the rings of Saturn. The objects in the Oort cloud are separated by distances measured in tens of millions of kilometers, so that collisions between them are almost unimaginably rare. But collectively, they form a great bubble around our solar system, a relic of its formation, a reservoir of comets that occasionally fall inward toward the Sun after journeys lasting millions of years. The inner edge of the Oort cloud is thought to begin somewhere around 2,000 to 5,000 Australian dollars from the Sun. Its outer edge may extend as far as 100,000 Australian dollars, which is a distance so great that it begins to blur into another unit of measurement entirely. At 100,000 Australian dollars, you are nearly 1.6 light-years from the Sun. You have reached the very edge of the Sun's gravitational influence, the point where the gentle tug of our star is matched by the combined pull of all the other stars in the galaxy. Think about what this means. The Sun's realm, the space over which its gravity holds sway, extends nearly a quarter of the way to the nearest star. The Oort cloud is not a sharp boundary but a gradual fading, a region where the Sun's influence slowly gives way to the wider galaxy. Beyond it lies true interstellar space, the vast emptiness between the stars, where the nearest suns are years of travel away even at the speed of light. We stand on Earth, warmed by a star 150 million kilometers distant, and we imagine that we live in a contained system, a neat arrangement of planets circling a central fire. But the truth is that our system extends far beyond the last planet, far beyond the Kuiper belt where Pluto resides, out into a darkness so deep and so cold that no human words can truly convey it. And at its farthest edge, it touches the beginning of something even larger, a realm where the distances are measured not in astronomical units but in light years. We will cross that threshold soon. But for now, let us rest here, floating in the stillness at the edge of the Oort cloud, looking back toward the distant spark that is our Sun. From here, it is just another star, one among hundreds of billions. And ahead, in the darkness, the first true stars of the galaxy are beginning to call us onward. We have journeyed now to the edge of the Sun's dominion, to that faint boundary where the Oort cloud begins to dissolve into the vastness between the stars. And here we must pause because the distances we are about to traverse require a new kind of language, a new unit of measure that has nothing to do with the kilometers and astronomical units we have used so far. The numbers have grown too large for our earthbound minds to hold comfortably, and so astronomers have given us a different kind of ruler, one that is rooted not in the dimensions of our planet or our orbit, but in the very nature of light itself. We call this measure the light year, and despite its name, it has nothing to do with time. It is a distance, pure and simple, the distance that light travels in 1 year, moving at its unchangeable speed of approximately 300,000 kilometers every second. In the time it takes you to draw a single slow breath, light has circled the Earth more than 7 times. In the time it takes to blink, it has traveled from New York to London and back again. And in the course of 1 year, moving at this unimaginable speed, light covers about 9.46 trillion kilometers. That is 9,460,000,000,000 kilometers, a number so vast that writing it in digits begins to feel like a kind of incantation, a string of zeros stretching toward infinity. Why do we need such a gigantic measure? Because the distances between the stars are so immense that even the astronomical unit, our faithful companion through the solar system, becomes hopelessly small. Remember that 1 AU is 150 million kilometers, the distance from Earth to the Sun. The nearest star to our own Sun, a faint red dwarf called Proxima Centauri, lies at a distance of about 265,000 Australian dollars from us. Let that number settle for a moment. 265,000 times the distance from Earth to the Sun. If you tried to express that distance in kilometers, you would be writing a number with more than 14 digits. But in light years, Proxima Centauri is just 4.24 light years away. For 0.24, it sounds almost manageable, almost close enough to reach out and touch. And yet, to cross those 4.24 light years in our imaginary airliner, flying at the speed of a commercial jet, would take more than 5 million years. 5 million years of continuous flight, generation after generation living and dying aboard a vessel that would never reach its destination within any single human lifetime. The light from Proxima Centauri that reaches your eyes tonight, if you could see it, which you cannot because it is far too faint, began its journey toward you more than 4 years ago. It has been traveling ever since, crossing the void at the universe's ultimate speed limit, and only now is it arriving. Let us try to feel this distance in another way. Imagine shrinking the entire solar system down to the size of a small coin, say a quarter, placed on a table in front of you. On this scale, the sun would be a microscopic speck at the center of the coin, and the planets would be invisible motes of dust orbiting at distances measured in millimeters. Now, where would the nearest star be? If your coin-sized solar system rests on a table in New York City, then Proxima Centauri on the same scale would be another coin-sized system located somewhere in the vicinity of Chicago, nearly 1,200 kilometers away. That is the emptiness between the stars. That is the scale we are now entering. The space between our sun and the next star is not empty in the absolute sense. It contains trace amounts of gas and dust, the occasional rogue comet, the faint whisper of particles from long-dead supernovae. But for all practical purposes, it is a void so profound that it dwarfs everything we have encountered so far. And here is a thought that carries both wonder and a kind of gentle melancholy. The stars you see on a clear night are not where they appear to be. When you look at the constellation Orion, for example, you are seeing light that left Betelgeuse, the red giant at Orion's shoulder, about 600 years ago. That light began its journey toward you centuries before the first European explorers crossed the Atlantic, before the printing press was invented, before the fall of Constantinople. It has been traveling through space all that time, passing through regions of unimaginable emptiness, and only now is it arriving at your eyes. The star itself may have changed in those 600 years. It may even have exploded in a supernova, though the news of that event will not reach Earth for many centuries yet. When you look at the stars, you are not seeing the present. You are seeing the past, layer upon layer of it, each star offering you a snapshot of a different moment in the history of the galaxy. This is one of the most profound truths that astronomy teaches us. That space and time are woven together, that to look outward is inevitably to look backward. The farther away an object is, the further back in time we see it. The moon, close as it is, appears to us as it was about 1.3 seconds ago. The sun as it was about 8.3 minutes ago. Jupiter as it was about 35 to 50 minutes ago, depending on its position in its orbit. Pluto as it was about 5.5 hours ago. And Proxima Centauri, the nearest star, as it was 4.24 years ago. This gentle lag, this cosmic delay, means that the universe we observe is a kind of vast historical archive, each object a document from a different era. There is no way to see the universe as it is right now at this moment. The very concept of right now loses its meaning when distances become this large. We stand on Earth, bathed in light that has traveled across unimaginable gulfs, and we try to make sense of it all. The light year, that simple phrase, contains within it both the speed of light and the depth of time. It is our bridge to the stars, our measure of the void. And now, armed with this new understanding, we are ready to take the next step. We will leave the solar system behind entirely and venture out into the galaxy, into the realm of hundreds of billions of suns, each one separated from its neighbors by distances measured in these same light years. But before we go, let us rest here for a moment at the threshold, looking out at the darkness between the stars. It is empty, yes, but it is also full of possibility, full of light that is always on its way, full of stories that have not yet reached us. We have crossed the threshold now. The sun, our star, the giver of life and light, has shrunk behind us until it is just one among many, a faint point of warmth in an ocean of cold. We are adrift in the space between stars, in the realm that separates our solar system from the wider galaxy. And here, in this profound emptiness, we must confront a new kind of scale, one that makes even the vast distances within the Oort cloud seem almost cozy by comparison. The space between stars is not merely empty. It is empty on a scale that human language struggles to convey. If you were standing on a planet orbiting Proxima Centauri, looking back toward our sun, you would see it as we see Proxima tonight. A faint, reddish point of light, indistinguishable from thousands of others except by its slight motion over centuries. The connection between our sun and its nearest neighbor is not a connection at all in any human sense. They are isolated islands of light, separated by an ocean of darkness so wide that it takes light itself more than 4 years to cross. Let us linger here for a while, floating in this interstellar void. There is no up or down, no left or right, only the slow, silent drift of the galaxy itself, carrying everything: stars, planets, dust, and us, in a great circular dance around a center we cannot see. The nearest star to our current position, whichever direction we choose, is years away at the speed of light. If our imaginary airliner were to attempt that journey, it would require not millions but tens of thousands of generations, a continuous lineage of humans living and dying in transit, never knowing a world beyond the metal walls of their vessel. The very thought is enough to induce a kind of vertigo, a dizzying sense of the immense solitude that pervades the cosmos. And yet, this solitude is an illusion of perspective. For we are not alone in this void. We are surrounded by hundreds of billions of other suns, each one a potential home to worlds we cannot yet see, each one burning its fuel in patient silence, waiting for the day when some intelligence might turn its instruments toward it and wonder. But before we can truly appreciate the scale of the galaxy, we must first understand that our sun and Proxima Centauri are not isolated wanderers. They belong to a neighborhood, a local cluster of stars bound together by gravity and by their shared journey through the galaxy. Astronomers call this the local interstellar cloud, a tenuous wisp of gas and dust about 30 light-years across, through which our sun has been passing for perhaps the last few tens of thousands of years. Within this cloud, there are several dozen stars, all drifting together like a loose school of cosmic fish. Beyond this cloud lies the local bubble, a vast cavity in the interstellar medium carved out by ancient supernova explosions, within which our sun and many nearby stars reside. These structures, invisible to the naked eye, shape the environment through which our solar system moves, influencing the amount of cosmic radiation that reaches Earth and the nature of the particles that stream outward from the sun. Now let us expand our view further. The stars nearest to us, those within about 20 light-years, form a kind of suburban sprawl around the sun. There is Alpha Centauri, a triple star system that includes Proxima. There is Barnard's star, a faint red dwarf that is moving across the sky faster than any other star, a cosmic traveler racing through the galactic neighborhood. There is Wolf 359, familiar to some as the site of a famous fictional battle, but in reality a dim, cool star less than 8 light-years away. There is Sirius, the brightest star in Earth's night sky, a blue-white gem located about 8.6 light-years distant, accompanied by a tiny white dwarf companion. These are our neighbors, the stars that share our region of the galaxy. They are close enough that their light reaches us in less than a decade, close enough that we could, in principle, send messages to any planets that might orbit them and receive a reply within a human lifetime. And yet, even this nearest handful of stars is separated by distances that dwarf everything we have encountered so far. Between Sirius and the Sun, you could place thousands of solar systems like ours end to end and still have room left over. As we continue to expand our view, we begin to see patterns in the distribution of stars. They are not scattered randomly, like salt sprinkled on a dark cloth. They are gathered into clusters and streams, into associations born of common origin in giant molecular clouds millions of years ago. The Pleiades, that tiny dipper of stars so beloved in northern skies, is one such cluster. A group of hot, young stars still moving together through space, still wrapped in the faint traces of the nebula from which they were born. The Hyades, closer to us, is another, a V-shaped cluster that forms the face of Taurus the Bull, its stars drifting together toward a common destiny. These clusters are temporary in cosmic terms. Over hundreds of millions of years, the gravitational tides of the galaxy will pull them apart, scattering their member stars across the vastness of the Milky Way, so that future observers will never know they were once siblings. But for now, they remain together, a reminder that even in the immense emptiness of space, there is companionship. We have traveled now from the Sun to the nearest stars, from the familiar to the unknown. We have begun to grasp the scale of the interstellar void, the distances that separate one sun from another. But we have not yet begun to comprehend the galaxy itself. That will be our next step, our next expansion of perspective. For now, let us rest in the knowledge that our sun is not alone, that it has neighbors, that it moves through a community of stars bound together by gravity and by the slow, patient drift of cosmic time. And as we rest, let us look out at the darkness around us and imagine all the light that is on its way, all the photons that have been traveling for years, decades, centuries, to reach the eyes of some future observer on a world we cannot yet imagine. Now we must expand our view once more, pulling back from the local neighborhood of stars to take in the grand structure that contains them all. Imagine yourself floating far above the plane of our galaxy, so high that the individual stars blur together into a luminous haze. Below you, stretching across the darkness like a great cosmic river, lies the Milky Way. It is a disk of light, slightly bulging at the center, with spiral arms winding outward in a graceful, slow-motion dance. This is our home in the largest sense, the galaxy to which our sun belongs, the vast collection of stars and gas and dust that orbits a common center under the pull of its own immense gravity. And it is, by any human measure, almost impossibly large. Let us begin with the numbers, though numbers alone cannot convey the reality of what we are about to describe. The Milky Way galaxy is a disk approximately 100,000 to 120,000 light-years in diameter. That means that a beam of light, traveling at the universe's ultimate speed limit, would need 100,000 years to cross from one side of the galaxy to the other. 100,000 years. When that light beam began its journey, our ancestors were still living in the Pleistocene, sharing the world with woolly mammoths and saber-toothed cats. They had not yet begun to farm, had not yet built the first cities, had not yet invented writing or mathematics or any of the things we think of as civilization. They were hunter-gatherers, wandering the savannas and forests of Africa, Europe, and Asia, living lives that would be almost unrecognizable to us today. And in all the time that has passed since then, through the entire span of human history, through the rise and fall of empires, through the birth of philosophy and science and art, that beam of light has been traveling. And only now, at this moment, as you lie here listening to these words, is it finally completing its journey from one side of our galaxy to the other. Now consider the thickness of the galactic disk. It is not uniform. The central bulge is roughly 16,000 light-years thick, while the spiral arms are much thinner, perhaps only 1,000 light-years from top to bottom. This flatness is a result of the galaxy's rotation, which has flattened it over billions of years into a shape not unlike a spinning pizza dough. And within this thin disk, our sun occupies a specific location. We are not at the center, not even close. We are situated in a minor spiral arm called the Orion Arm, or sometimes the Orion Spur, located about 26,000 light-years from the galactic center. To visualize this, imagine the Milky Way as a vast city of light. The center is the downtown area, crowded and bright, packed with stars wheeling in complex orbits around a supermassive black hole. Our sun, by contrast, lives in the suburbs, in a relatively quiet residential neighborhood where the stars are more spread out and the pace of life is slower. From our vantage point, we look inward toward the bustling center and outward toward the sparser fringes, and we see the Milky Way as a band of light stretching across the night sky. Let us try to feel what it means to be 26,000 light-years from the galactic center. Light from the stars near that center takes 26,000 years to reach us. When we look in that direction, we are seeing the galaxy as it was at the end of the last ice age, when humans were just beginning to domesticate dogs and carve the first tiny figurines from mammoth ivory. The light from stars on the opposite side of the galaxy, 50,000 or 60,000 light-years beyond the center, takes even longer to arrive. And yet, all of this light, from all across the galaxy, is streaming toward us constantly, a silent rain of photons carrying information about places and times we can never visit in person. Now, what of the number of stars in this great disk? Here, we must rely on estimates because we cannot count them individually. Our best observations, combined with models of galactic structure, suggest that the Milky Way contains between 100 billion and 400 billion stars. Let us pause to consider that range. Even the lower estimate, 100 billion, is a number so vast that it resists comprehension. If you were to try to count to 100 billion at a rate of one number per second without stopping to sleep or eat, it would take you more than 3,000 years. And the higher estimate for 100 billion would take you nearly 13,000 years. Each of those stars is a sun, potentially with its own system of planets, its own history, its own possibilities for life. Each one is burning its nuclear fuel in the darkness, radiating light and warmth into the void. And each one is moving, orbiting the galactic center in a great slow waltz that takes hundreds of millions of years to complete one turn. Our sun, with its family of planets, is just one among these hundreds of billions. It is an average star, neither particularly large nor particularly small, neither exceptionally bright nor exceptionally dim. It resides in an average location, in an average spiral arm, in an average galaxy. And yet, from our perspective, it is everything. It is the source of our light, the anchor of our world, the reason we exist at all. This tension between the cosmic and the personal, between the vastness of the galaxy and the intimacy of our own star, is one of the themes that will accompany us as we continue our journey outward. We are small, yes, but we are also here, conscious and aware, capable of marveling at the immensity that contains us. In that capacity for wonder, perhaps, lies something that is not small at all. As we prepare to leave the Milky Way and venture into the space between galaxies, let us take a moment to appreciate where we have been. We have traveled from our own planet to the moon, from the moon to the sun, from the sun to the edge of the solar system, from the solar system to the nearest stars, and now to the scale of the galaxy itself. Each step has required us to abandon familiar measures and adopt new ones, to let go of our intuitive sense of distance and embrace numbers that stretch the imagination to its breaking point. And yet, we are not done. Beyond the Milky Way lies a universe of galaxies, each one a vast island of stars, each one separated from its neighbors by distances that make the spaces between stars seem like a mere stone's throw. But that is a journey for another section. For now, let us rest here, floating above the plane of our galaxy, watching the slow turn of its spiral arms, and feeling, perhaps for the first time, the true scale of our cosmic home. We have spent time now within the vast disk of our Milky Way, floating among its hundreds of billions of suns, feeling the slow pull of its gravity and the gentle sweep of its spiral arms. But to truly understand our place in the cosmos, we must now do something that challenges every instinct born of life on a single planet. We must leave our galaxy behind. Not physically, of course, but in imagination. We must pull back so far that the Milky Way itself becomes just another object in the sky, a faint smudge of light among many. And when we do, we will discover that our galaxy is not alone. It is part of a larger community, a collection of galaxies bound together by gravity, moving through space as a single entity. Astronomers call this the local group, and it is our galactic neighborhood. Let us begin our journey outward by locating our nearest major neighbor. If you are ever under a truly dark sky, far from the lights of cities and towns, you might notice a faint, hazy patch in the constellation of Andromeda. To the naked eye, it appears as little more than a smudge, a small cloud that seems slightly out of focus compared to the sharp points of stars around it. But that smudge is in fact another galaxy, a vast island of stars very much like our own, containing perhaps 1 trillion suns. It is the Andromeda Galaxy, and it is approaching us at about 110 kilometers per second. In about 4.5 billion years, it will collide with the Milky Way, the two great spirals merging into a single elliptical galaxy that astronomers have already nicknamed Milkomeda. But that is far in the future. For now, Andromeda lies at a distance of approximately 2.5 million light-years from Earth. The light we see from it tonight began its journey toward us 2.5 million years ago, when our ancestors were just beginning to walk upright on the African savanna, when the first stone tools were being chipped from river cobbles, when the world was a very different place. 2.5 million light-years. Let that number settle in your mind. It is more than 20 times the diameter of the entire Milky Way. The space between our galaxy and Andromeda is not empty. It contains a sparse population of stars, perhaps some rogue planets and tenuous clouds of gas. But for all practical purposes, it is a void so vast that it makes the interstellar gulfs we crossed earlier seem like the distance between neighboring houses. If our Milky Way were the size of a dinner plate, Andromeda would be another dinner plate located about 25 meters away. That gap, 25 meters on this scale, represents millions of light years of actual space, an emptiness so profound that it challenges the very limits of our ability to imagine. But the local group contains more than just the Milky Way and Andromeda. Orbiting around these two giants, like moons around planets, are dozens of smaller galaxies. The most famous of these, at least for us, are the Large and Small Magellanic Clouds, two irregular dwarf galaxies that are visible to the naked eye from the southern hemisphere. They are named for the explorer Ferdinand Magellan, whose crew recorded them during their circumnavigation of the globe in the early 16th century. These clouds of stars are about 160,000 and 200,000 light-years from Earth, respectively, making them among our closest galactic neighbors. They are actively forming new stars, their gas clouds lit by the intense radiation of hot, young suns. In the Large Magellanic Cloud, in 1987, astronomers witnessed one of the most significant events in modern astronomy. A supernova, the explosive death of a massive star, visible to the naked eye for months. That light had been traveling for 168,000 years to reach us, beginning its journey when our ancestors were still living alongside Neanderthals in Ice Age Europe. There are many other dwarf galaxies in the local group, most too faint to be seen without powerful telescopes. There is the Triangulum Galaxy, also known as M33, a small spiral galaxy about 2.7 million light-years away, possibly a satellite of Andromeda. There are the Ursa Minor dwarf, the Draco dwarf, the Sculptor dwarf, and dozens more, each one a faint collection of stars orbiting the larger members of the group. Altogether, the local group contains more than 50 known galaxies, though the exact number depends on how you define the boundaries of the group and how you count the faintest, most diffuse members. These galaxies are bound together by gravity, moving through space as a single system, isolated from other similar groups by even vaster distances. Now, let us try to grasp the scale of this local group. Its diameter is roughly 10 million light-years. That is the distance from one side of the group to the other, a span so great that light takes 10 million years to cross it. Within this volume, the galaxies are arranged not randomly but in two main subgroups centered on the Milky Way and Andromeda, with a scattering of smaller galaxies in between. Our Milky Way, along with its retinue of dwarf satellites, is falling toward Andromeda at a speed that will eventually bring them together. But eventually here means billions of years, a span of time so far beyond human experience that it becomes almost abstract. The universe operates on timescales that dwarf our own, and the dance of galaxies is a slow, stately waltz that makes the movement of continents on Earth seem frantic by comparison. As we float here at the edge of the local group, looking back at the collection of galaxies that includes our own, we might begin to feel a new kind of vertigo. We have left not just our planet, not just our solar system, not just our galaxy, but our entire galactic neighborhood behind. Ahead of us lies something even larger, even more encompassing. The Virgo supercluster, a vast assemblage of galaxy groups and clusters of which the local group is just a tiny part. But before we venture there, let us rest in the knowledge that we belong to a community of galaxies, that our Milky Way is not alone in the universe, that it has neighbors and companions moving with it through the great cosmic dark. And as we rest, Let us imagine what it would be like to stand on a world in the Andromeda Galaxy, looking back across 2.5 million light-years of void toward the faint spiral of our home, and wondering, as we wonder now, whether anyone out there is looking back. We have now left the local group behind, that small cluster of galaxies bound together by gravity, and we are floating in a much vaster space. Ahead of us, or rather all around us, lies a structure so immense that it defies easy description. This is the Virgo supercluster, a vast collection of galaxy groups and clusters that stretches across more than 110 million light-years of space. Within this supercluster, the local group is just one tiny component, a small cluster of galaxies orbiting among hundreds of others. And yet, even the Virgo supercluster is not the largest structure we will encounter. It is merely the next step in our outward journey, a waypoint on the path to understanding the true scale of the cosmos. Let us begin by locating ourselves within this immense structure. The Virgo supercluster is named for the Virgo cluster, a dense concentration of galaxies located about 50 to 60 million light-years from Earth, in the direction of the constellation Virgo. The Virgo cluster contains somewhere between 1,300 and 2,000 galaxies, including massive ellipticals and spirals, all packed into a volume about 15 million light-years across. It is the gravitational heart of our supercluster, the region toward which many nearby groups, including our own local group, are slowly falling. The Milky Way, along with Andromeda and their retinue of dwarf galaxies, is moving toward the Virgo cluster at a speed of several hundred kilometers per second, though the distance is so great that we will never actually reach it. The expansion of the universe, which we will discuss later, complicates this motion, but for now, it is enough to know that we are part of a great cosmic flow, a river of galaxies all drifting toward a common center. To truly appreciate the scale of the Virgo supercluster, we need to visualize its structure. Imagine a vast, irregular cloud of galaxies, with the Virgo cluster as its dense core. Surrounding this core are numerous smaller groups and clusters, arranged in a roughly flattened disk that is perhaps 30 to 40 million light-years thick and more than 100 million light-years across. Our local group is one of these outlying groups, located on the outskirts of the supercluster, far from the crowded center. From our vantage point, we look toward the Virgo cluster and see it as a rich field of galaxies, a dense swarm of islands in an otherwise relatively empty ocean. And beyond the Virgo cluster, on the far side of the supercluster, lie other groups and clusters, each one a collection of hundreds or thousands of galaxies, each one moving under the influence of the combined gravity of all the others. Now, let us consider what it means to be 110 million light-years across. A beam of light traveling at 300,000 kilometers per second would need 110 million years to cross the Virgo supercluster from one side to the other. When that light beam began its journey, the Earth was in the midst of the Cretaceous period, the age of dinosaurs. The great reptiles still ruled the land. The first flowering plants were spreading across the continents, and the mammals that would eventually give rise to humans were small, shrew-like creatures scurrying through the undergrowth. In all the time that has passed since then, through the extinction of the dinosaurs, the rise of mammals, the evolution of primates, the emergence of our own species, the entire span of human history, that light has been traveling. And only now, as you listen to these words, is it finally completing its journey. This is the scale we are now dealing with. The millions of years that once seemed so vast, so incomprehensible, have become the units in which we measure the distances between structures in the universe. Within the Virgo supercluster, Galaxies are not distributed uniformly. They are gathered into groups and clusters, separated by voids that are largely empty of bright galaxies. These voids can be tens of millions of light-years across vast regions of space where the density of galaxies is only a tiny fraction of the average. Our own local group, for example, is surrounded by a relatively empty region known as the local void, which extends for perhaps 150 million light-years in some directions. This void is not completely empty. It contains a few isolated galaxies and clouds of gas, but it is a desert compared to the crowded regions near the center of the supercluster. We live on the edge of this void, looking out across its emptiness toward the distant lights of other galactic communities. As we continue to expand our view, we begin to see patterns in the distribution of superclusters themselves. They are not randomly scattered across the universe. Instead, they are arranged in vast filaments and sheets, great walls of galaxies that stretch for hundreds of millions of light-years, surrounding immense voids where few galaxies exist. This structure, often called the cosmic web, is the largest known pattern in the universe. It is the result of gravitational instabilities in the early universe, amplified over billions of years, until the matter we see today has been pulled into a complex network of dense regions and empty spaces. Our Virgo supercluster is part of one such filament, a thread in the cosmic web that connects us to other superclusters across even greater distances. We are beginning to approach the limits of what we can observe, the boundaries of the visible universe. But we are not there yet. Before we reach that ultimate horizon, we must take one more step, one more expansion of perspective. We must leave the Virgo supercluster behind and consider the structure that contains it. The Laniakea supercluster, a vast assembly of galaxies and superclusters that dwarfs everything we have encountered so far. But that is a journey for another section. For now, let us rest here, floating in the vast spaces between galaxy clusters, looking out across the cosmic web, and feeling the slow, patient pull of gravity as it shapes the largest structures in the universe. We have journeyed now through ever-expanding scales, from our small planet to the vastness of the Virgo supercluster. But the universe, as we are beginning to understand, has no end to its layers of structure. Just when we think we have grasped the largest possible thing, we discover that it is merely a part of something even larger. So it is with the Virgo supercluster. For decades, astronomers believed that this collection of galaxy groups and clusters, stretching 110 million light-years across, was the largest structure to which our local group belonged. But more recent mapping of the velocities and positions of galaxies has revealed a different picture. The Virgo supercluster is itself just a small part of an even more immense assembly, one so large that it has been given a name drawn from the Hawaiian language, Laniakea, which means immeasurable heaven. Let us take a moment to appreciate this name, for it carries within it a kind of poetry that suits the scale we are about to explore. Laniakea, immeasurable heaven. It was chosen to honor the Polynesian navigators who crossed the vast Pacific Ocean, guided by stars and currents, finding their way across distances that seemed impossible to those who did not understand their art. And now we, too, are navigators, crossing distances far greater than any ocean, guided not by stars but by the light of galaxies, seeking to understand the shape of the cosmic shore on which we find ourselves. The Laniakea supercluster is a vast collection of galaxies, galaxy groups, and smaller superclusters that spans approximately 520 million light-years across. Within this immense volume, our own Virgo supercluster is just one of many components, a single lobe in a much larger structure. The gravitational center of Laniakea, the point toward which all its constituent galaxies are flowing, is a region known as the Great Attractor. This is not a single object but a dense concentration of mass, hidden from our view by the disk of our own galaxy, that pulls at everything within hundreds of millions of light years. The Milky Way, along with every other galaxy in Laniakea, is slowly drifting toward this unseen attractor, moving at hundreds of kilometers per second through the cosmic void. Let us try to grasp what 520 million light years means. A beam of light traveling for 520 million years would just now be completing a journey that began during the Cambrian period, when life on Earth was still confined to the seas, when the first complex organisms were just beginning to evolve, when the continents were barren rock under a sky that would have looked strange and alien to our eyes. The entire history of complex life on Earth, from the first trilobites to the age of dinosaurs to the rise of mammals to the emergence of humans, is contained within the time it takes light to cross the Laniakea supercluster. And Laniakea itself is just one of many such superclusters in the observable universe. Within Laniakea, the galaxies and clusters are arranged in a complex web of filaments and sheets, tracing the gravitational skeleton of the cosmos. There are dense nodes where many clusters come together, and long, thread-like structures where galaxies string out like beads on a necklace. There are great voids where almost nothing exists, regions of space hundreds of millions of light years across that contain only a handful of isolated galaxies. Our own local group, with its 50-odd galaxies, is located in a relatively quiet region of Laniakea, far from the densest concentrations, on the outskirts of the Virgo supercluster lobe. We are, in a sense, cosmic suburbanites, living in a quiet neighborhood far from the bustling downtown regions where clusters merge and galaxies collide. The discovery of Laniakea, announced in 2014, was made possible by a new way of mapping the universe. Instead of simply plotting the positions of galaxies, astronomers measured their velocities, using the Doppler shift of their light to determine how fast they are moving and in what direction. By tracing these motions, they could map the gravitational landscape of the local universe, identifying the basins of attraction that pull galaxies toward common centers. What they found was that our entire Virgo supercluster is flowing toward a region called the Norma cluster, a dense concentration of galaxies hidden behind the Milky Way's central bulge. This flow defines the boundaries of Laniakea, separating it from neighboring superclusters like Perseus Pisces and Coma, which are flowing toward their own attractors. Now, here is a thought to carry with you as we float in this immense space. The boundaries between superclusters are not sharp lines. There is no wall, no fence, no clear marker where one supercluster ends and another begins. Instead, these are regions of space where the gravitational influence of one attractor gives way to another, where galaxies are no longer falling toward one center but toward a different one. We are part of Laniakea because we are falling toward the Great Attractor. If we were falling toward something else, we would belong to a different supercluster. In this sense, our cosmic address is not a fixed thing but a dynamic one, defined by the flow of galaxies through space. As we prepare to take the final step in our outward journey, to the edge of the observable universe itself, let us rest for a moment in the immensity of Laniakea. 520 million light years, thousands of galaxies, each containing hundreds of billions of stars, countless worlds, countless possibilities, all moving together in a slow cosmic dance toward a common center. And we, tiny creatures on a small planet orbiting an average star in an ordinary galaxy, have somehow found a way to know this, to map it, to name it. In that knowledge, there is both humility and wonder. We are small, yes, but we are also aware. And in that awareness, perhaps, lies something that transcends size. We have now arrived at the threshold of the known. Beyond Laniakea, beyond the flow of galaxies toward the great attractor, lies a realm that challenges not only our sense of scale but our very understanding of what the universe is. This is the observable universe, the vast sphere of space from which light has had time to reach us since the beginning of cosmic time. It is not the entire universe. What lies beyond it is, by definition, forever hidden from our view. But it is everything we can see, everything we can measure, everything we can know. And its size, as we are about to discover, is almost beyond comprehension. Let us begin with a number that has become almost iconic in astronomy. The diameter of the observable universe is approximately 93 billion light-years. 93 billion. Let that number settle in your mind for a moment. 93 billion light-years across. A beam of light traveling at 300,000 kilometers every second would need 93 billion years to cross from one side of the observable universe to the other. But here is the strange and wonderful thing. The universe itself is only about 13.8 billion years old. How can we see something 93 billion light-years across if light has only had 13.8 billion years to travel? The answer lies in the expansion of space itself. The universe is not static. It has been stretching, inflating like a cosmic balloon, ever since the moment of its birth. The galaxies we see at the edge of the observable universe were much closer to us when their light began its journey, but in the billions of years since, the expansion of space has carried them far away. They are now 46.5 billion light-years from us in every direction, making the total diameter of the observable sphere 93 billion light-years. This is a concept that can make the mind reel. The universe is not only vast in space, it is vast in time, and the two are woven together in ways that defy our everyday intuition. When we look out to the farthest reaches of the observable universe, we are looking back in time nearly to the beginning itself. The most distant galaxies we have ever seen, captured in images like the Hubble Ultra Deep Field, appear to us as they were just a few 100 million years after the Big Bang. Their light has been traveling for more than 13 billion years, stretched by the expansion of space from short ultraviolet wavelengths to the longer infrared wavelengths that our telescopes can detect. We are seeing these galaxies in their infancy, when they were first forming their first stars, when the universe was young and full of possibility. Now, let us consider what lies within this immense sphere. The observable universe contains an estimated 200 billion galaxies, though some recent studies suggest the number could be as high as 2 trillion. 2 trillion galaxies, each one containing hundreds of billions of stars. If we take the lower estimate of 200 billion galaxies and multiply by the average number of stars per galaxy, say 100 billion, we get a total of 20,000 billion stars, or 2 followed by 22 zeros. That is more stars than there are grains of sand on every beach on Earth. And if the higher estimate of 2 trillion galaxies is correct, then the number of stars is 10 times larger still. These numbers are so vast that they cease to have meaning in any human sense. They become abstractions, symbols on a page, pointing toward a reality that our brains are simply not equipped to grasp. But let us try, nonetheless, to feel something of this immensity. Imagine that you could visit one star per second, spending no time traveling between them, just instantaneously moving from one sun to the next. At that rate, it would take you more than 600 trillion years to visit every star in the observable universe. That is more than 40,000 times the current age of the universe. And during all that time, new stars would be forming and old stars dying. The universe itself would be continuing to expand, and the very fabric of space would be stretching beneath your feet. The scale is not just large, it is effectively infinite for all practical purposes, even though we know the universe is finite. Within this vast ocean of stars and galaxies, our own Milky Way is just one among billions. Our sun is just one among billions in our galaxy. Our planet is just one among perhaps many in our solar system. And we, the human species, have existed for only an instant of cosmic time, on a single world orbiting an unremarkable star in the suburbs of an ordinary galaxy. From one perspective, this is the ultimate statement of human insignificance. But from another perspective, it is the ultimate statement of human wonder. We have, through curiosity and intelligence and the patient accumulation of knowledge, managed to comprehend, at least in outline, the vastness of the cosmos that contains us. We have mapped the universe from our small planet to the edge of the observable. We have told the story of its birth and its evolution, at least in broad strokes. And we have done all of this in just a few thousand years of civilization, a blink of an eye in cosmic terms. As we float here, at the edge of the observable universe, looking back toward the distant speck that is our home, we might feel a complex mixture of emotions. Awe at the immensity, humility at our smallness, gratitude for our awareness, and perhaps a touch of loneliness. The universe is vast and mostly empty, and we have found no other voices in the darkness. But the search continues, and the universe is full of possibilities we have not yet imagined. For now, let us rest in the knowledge that we have seen as far as it is possible to see, that we have reached the limits of the observable, and that what lies beyond is, for now, a mystery that may never be solved. We have journeyed now to the very edge of the observable universe, to the limits of what can be seen from our small planet. But before we begin our slow drift back toward home, there is one more perspective we must consider, one more layer of understanding that can deepen our appreciation for the cosmos we inhabit. This is the perspective of time. For the universe is not only vast in space, it is vast in duration, and the two dimensions are intimately connected. The light that reaches us from distant galaxies has been traveling for billions of years, carrying with it images of the past. When we look out, we look back, and in doing so, we catch glimpses of the universe at different stages of its long evolution. Let us begin with the nearest objects and work our way outward in time. The moon, as we noted earlier, is about 1.3 light seconds away. We see it as it was 1.3 seconds ago. The sun is about 8.3 light minutes distant. If the sun were to suddenly vanish, we would not know it for more than 8 minutes. The outer planets are light hours away. Pluto, at its average distance, is about 5.5 light hours from us. When we look at Pluto through a telescope, we are seeing it as it was 5.5 hours ago. This time lag is negligible on human scales, but it is real, and it reminds us that we never see the universe as it is now, only as it was when its light began its journey. As we move outward, the time lags become more significant. The nearest stars are light years away. When we look at Alpha Centauri, we see it as it was 4.4 years ago. When we look at Sirius, 8.6 years ago. When we look at Betelgeuse, that red giant in Orion's shoulder, we see it as it was about 600 years ago, around the time of the Black Death in Europe. The light from Betelgeuse has been traveling since the Middle Ages, passing through space all that time, and only now is it arriving at our eyes. And if Betelgeuse has already exploded, as it may, sometime in the next 100,000 years, we will not know it until the light of that explosion reaches us, perhaps centuries or millennia from now. Now let us go further. The Andromeda Galaxy is 2.5 million light-years away. When we look at it, we see it as it was 2.5 million years ago, when our ancestors were just beginning to make the first stone tools, when the world was in the Pliocene epoch, when the climate was warmer and the continents were in slightly different positions. The light we see from Andromeda today began its journey before there were modern humans, before there were Neanderthals, before there were any hominins that we would recognize as our kin. It has been traveling all that time, crossing the void between galaxies, and only now is it completing its journey. The Virgo cluster, that dense concentration of galaxies that forms the heart of our supercluster, is about 50 to 60 million light-years away. When we look at those galaxies, we see them as they were in the Eocene epoch, when mammals were diversifying after the extinction of the dinosaurs, when the first primates were evolving, when the Earth was a very different place. The light from the Virgo cluster has been traveling since before the Himalayas began to rise, since before the great mountain ranges of the world had taken their current shapes. It has witnessed, in its long journey, the entire recent history of our planet. And the most distant galaxies we can see, those near the edge of the observable universe, are more than 13 billion light-years away. When we look at them, we see them as they were just a few 100 million years after the Big Bang, when the universe was young and hot, when the first stars and galaxies were just beginning to form. We are seeing these galaxies in their infancy, seeing the light that left them when the universe was only a few % of its current age. In a very real sense, we are looking at the universe's baby pictures, images of a time long before our sun or Earth existed. This connection between distance and time is one of the most profound insights of modern astronomy. It means that the universe is not a static collection of objects spread through space, but a dynamic, evolving entity whose history we can read in the light that reaches us. Every telescope is a time machine, and every observation is a journey into the past. The deeper we look, the further back we go until we reach the very limit of visibility. The cosmic microwave background radiation, the afterglow of the Big Bang itself, which has been traveling for 13.8 billion years and now fills the universe with a faint, uniform glow. As we prepare to begin our journey back toward home, let us carry with us this understanding of the universe as a place of deep time as well as vast space. The light that reaches our eyes tonight has traveled across unimaginable distances and through unimaginable ages to be here. It carries with it the history of the cosmos, written in wavelengths and intensities, waiting for us to read it. And we, tiny creatures on a small planet, have learned to read that language, to decode the messages written in ancient light. In doing so, we have connected ourselves to the larger story of the universe, becoming, in a small way, participants in its ongoing evolution. Now let us begin the slow journey back, the long drift homeward through the layers of structure we have crossed. But we will not simply retrace our steps. Instead, we will pause at each level to reflect on what it means, to feel the weight of these scales not as abstract numbers but as dimensions that shape our understanding of who and where we are. For the size of the universe is not just a fact to be memorized. It is a context that gives meaning to our existence, a backdrop against which the drama of human life unfolds. Let us start our return at the edge of the observable universe, that sphere 93 billion light-years across, beyond which we cannot see. From here, looking back toward the tiny point that is our home, we see the entire history of the cosmos laid out before us in shells of light. The most distant galaxies, faint and reddened by the expansion of space, are the youngest. Closer in, galaxies appear as they were billions of years later, their shapes more familiar, their stars more mature. And closest of all, the galaxies of our local supercluster appear almost as they are today, their light having traveled only millions of years to reach us. This layered view, this cosmic onion of time, is the true shape of the observable universe. We are at the center not because we are special, but because we are here, because this is the only vantage point we have. Now let us descend through the layers. We pass through the realm of the most distant quasars, those brilliant beacons powered by supermassive black holes at the centers of young galaxies. Their light has been traveling for more than 12 billion years, and in that light we can read the conditions of the early universe. The density of gas, the temperature of intergalactic space, the fingerprints of the first generations of stars. We pass through the era of galaxy formation, when the universe was a few billion years old and the great spirals and ellipticals were taking shape. We pass through the realm of mature galaxies, like our own, where stars have been forming and dying for billions of years, enriching the cosmos with the heavy elements necessary for life. As we continue downward, we enter the realm of superclusters, those vast assemblies of galaxy clusters that define the large-scale structure of the universe. We pass through Laniakea, our own supercluster, with its 500 million light-years of filaments and voids. We see the great attractor, that dense concentration of mass toward which we are all falling, and we feel the gentle pull of its gravity, a reminder that even on these immense scales, nothing is truly still. Everything moves, everything flows, everything participates in the great cosmic dance. Now we enter the Virgo supercluster, that smaller assembly that contains our local group. We see the Virgo cluster itself, that dense swarm of thousands of galaxies, and we feel its gravitational dominance over our region of space. We see the smaller groups and clusters scattered around it, like satellites orbiting a great city. And there, on the outskirts, we see our own local group, a small collection of a few dozen galaxies dominated by the Milky Way and Andromeda. Descending further, we enter the local group itself. We see Andromeda, that great spiral approaching us at 110 kilometers per second, destined to merge with our galaxy in about 4.5 billion years. We see the Triangulum galaxy, the third largest member of our group, a small spiral trailing behind Andromeda. We see the dozens of dwarf galaxies that orbit the larger members, some so faint they were discovered only recently. And there, in a quiet corner of the group, we see the Milky Way, our home galaxy, with its 100 billion stars and its spiral arms winding outward from a central bulge. Now we enter the Milky Way. We see its structure from above. The central bar, the spiral arms, the thin disk of young stars, the thick disk of older stars, the halo of globular clusters that surrounds it all. We see the Orion Arm, that minor spiral feature where our sun resides, and we follow it inward toward the galactic center. We pass through regions of star formation, where giant molecular clouds are collapsing to form new suns, and through regions of old red stars, where the light is faint and golden. We pass the black hole at the galactic center, that invisible mass of 4 million suns, around which everything in our galaxy orbits. Finally, we approach the sun. From a distance of thousands of light years, it is just another star, indistinguishable from its neighbors. But as we draw closer, it begins to stand out brighter and brighter until it dominates the sky. And within its light, we see the planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and all the smaller bodies that orbit with them. We see Earth, that blue marble hanging in the darkness, and we descend through its atmosphere, through the clouds, toward the surface. And here we are, back where we began, lying in a bed, or sitting by a window, or curled on a sofa, listening to the quiet of the night. The universe is still out there, as vast and silent as ever. But now, perhaps, we carry it with us in a different way. Not as a collection of facts, but as a presence, a context, a home. As we settle back into the familiar embrace of our planet, let us take a moment to reflect on what this journey has revealed about our place in the cosmos. We have traveled from the intimate scale of human experience to the farthest reaches of the observable universe. And in doing so, we have encountered a truth that is both humbling and exhilarating. We are simultaneously insignificant and precious, ordinary and extraordinary, a tiny part of something vast and a unique expression of its potential. Consider first our insignificance. In terms of physical scale, we are almost nothing. The Earth is a grain of sand in the vast desert of the solar system. The solar system is a microscopic speck in the ocean of the Milky Way. The Milky Way is one galaxy among hundreds of billions, indistinguishable from countless others. And the observable universe, for all its immensity, may itself be just a tiny fraction of a much larger cosmos, perhaps infinite in extent. On every scale we have examined, we have found ourselves dwarfed, diminished, rendered small. If size were the only measure of worth, we would have no worth at all. But size is not the only measure. Consider now our preciousness. As far as we know, we are the only conscious beings in the universe capable of asking these questions, of marveling at the night sky, of understanding the scale of the cosmos. In all the vastness of space, with its hundreds of billions of galaxies and its trillions of stars, we have found no other voice, no other signal, no other sign of intelligence. Perhaps there are others, and perhaps someday we will find them. But for now, we are alone, the sole representatives of awareness in a universe that seems, on the surface, to be empty and silent. This loneliness is a kind of burden, but it is also a kind of gift. It means that we matter, that our existence has meaning, that the universe has, in us, produced something that can look back at it and wonder. Consider, too, our connection to the cosmos. The atoms that make up our bodies were forged in the hearts of stars that lived and died billions of years ago. The carbon in our cells, the oxygen we breathe, the iron in our blood. All of it was created in stellar furnaces, scattered across space by supernova explosions, and gathered together again in the cloud of gas and dust that gave birth to our solar system. We are not separate from the universe. We are made of it. When we look up at the night sky, we are looking at our own origins. When we study the stars, we are studying the sources of our own existence. In a very real sense, we are the universe becoming aware of itself. This is a thought that has been expressed by poets and philosophers for centuries, but it is also a scientific fact. The elements that make up our world and our bodies were synthesized in stars. The processes that shaped our planet and our species are cosmic processes, governed by the same laws that govern the most distant galaxies. We are not visitors here. We are natives, born of this universe, adapted to its conditions, shaped by its history. And in our awareness, the universe has gained a voice, a way of telling its own story. Now, as we prepare to bring this journey to a close, let us consider what it means to carry this knowledge with us into our daily lives. The size of the universe is not just an abstract fact to be learned and forgotten. It is a perspective, a way of seeing ourselves and our world that can transform how we live. When we remember how small we are, our problems can seem less overwhelming, our conflicts less significant, our differences less important. When we remember how precious we are, our lives can seem more meaningful, our connections more valuable, our moments more worth savoring. The universe is vast and silent, but we are here, and that is enough. Let us also remember that our journey is not over. The universe we have explored tonight is only the observable universe, the part from which light has had time to reach us. Beyond that lies an unknown realm, perhaps infinite, perhaps structured in ways we cannot imagine, perhaps containing other conscious beings who are, at this very moment, looking out at their own skies and wondering about the nature of existence. We may never know what lies beyond our cosmic horizon, but we can continue to wonder, to explore, to push the boundaries of knowledge a little further with each generation. For now, though, let us rest. Let the vastness we have traveled settle gently around you like a soft blanket. Let the numbers and the light years fade into the background, and let the simple fact of your existence, here and now, in this quiet moment, become the center of your awareness. You are small, yes, but you are also here, and in this moment, that is enough. As we continue our gentle descent back into the familiar rhythms of earthly existence, let us pause to consider one of the most remarkable aspects of our journey: the fact that we could make it at all. The human mind, for all its limitations, has managed to comprehend scales that are literally billions of times larger than anything we can directly experience. We have measured the distances to stars, mapped the structure of galaxies, and calculated the size of the observable universe. We have done this not through any special ability to perceive these vast scales directly, but through the power of reason, mathematics, and the patient accumulation of observations. In a very real sense, we have transcended our biological limits, using our minds to reach across cosmic distances and touch the edge of eternity. Think about what this means. Our brains evolved on the African savanna, adapted to the challenges of finding food, avoiding predators, and navigating social relationships. They were not designed to comprehend billions of light years or billions of years. And yet, through culture, language, and science, we have built tools that extend our mental reach far beyond its biological origins. We have created mathematics to handle numbers too large to count, telescopes to see light too faint to detect, and theories to explain phenomena too distant to observe directly. The size of the universe is not just a fact about the cosmos. It is a testament to human ingenuity, a measure of how far we have come since our ancestors first looked up at the night sky and wondered. Consider, for a moment, the journey of a single photon of light from a distant galaxy. That photon may have been traveling for billions of years, crossing vast stretches of empty space, passing through clouds of gas and dust, dodging gravitational lenses, and finally, by an almost impossibly unlikely chance, entering the aperture of a telescope somewhere on Earth. There, it is focused by mirrors, captured by a detector, and converted into an electrical signal that is recorded and analyzed. And from that single photon, combined with billions of others, we can reconstruct an image of a galaxy as it was billions of years ago, when the universe was young and the first stars were just beginning to shine. This is not magic. It is science. But it is science that borders on the miraculous, a demonstration of what human curiosity and ingenuity can achieve. Yet this achievement comes with a cost. The more we learn about the universe, the more we realize how much we do not know. The observable universe, vast as it is, may be only a tiny fraction of a much larger cosmos. Some cosmologists speculate that our universe is just one of countless others in a vast multiverse, each with its own laws of physics, its own history, its own possibilities. If this is true, then the already incomprehensible scale of the observable universe becomes almost infinitely larger, and our place in the cosmos becomes even more difficult to grasp. But this is speculation, not science. For now, we must content ourselves with what we can observe and acknowledge that there may be realms of reality forever beyond our reach. The laws of physics themselves, as we understand them, may be only a local approximation of deeper principles we have yet to discover. Our theories of gravity, quantum mechanics, and cosmology are remarkably successful, but they are incomplete. We do not know what dark matter is, though it makes up most of the mass in the universe. We do not know what dark energy is, though it is causing the expansion of the universe to accelerate. We do not know whether the constants of nature are truly constant, or whether they vary over time and space. And we do not know whether the laws we have deduced are the only possible laws, or whether they are contingent on conditions we do not yet understand. And then there is the greatest question of all. Are we alone? In all the vastness of the universe, with its hundreds of billions of galaxies and its trillions of stars, is there other conscious life? We have been listening for signals for decades, scanning the skies for any hint of intelligent communication, and so far we have heard nothing but silence. This silence could mean many things. That life is rare, that intelligent life is even rarer, that technological civilizations are short-lived, that they are not using technologies we can detect, or that they are simply too far away for their signals to reach us. But it could also mean that we are alone, the only conscious beings in this vast cosmic ocean, the sole representatives of awareness in a universe that is otherwise empty and silent. And yet, this ignorance is not a cause for despair. It is an invitation to continue exploring, to keep asking questions, to push the boundaries of knowledge a little further with each generation. The universe is vast, but so is human curiosity. The darkness is deep, but so is our desire for light. And as long as we continue to wonder, to explore, to seek understanding, we are fulfilling something essential to our nature, something that connects us to the very origins of the cosmos from which we emerged. Let us also consider, in this quiet moment, the privilege of being alive at a time when these questions can be asked. For most of human history, the universe was a mystery, its scale completely unknown. Ancient peoples looked at the night sky and saw gods and heroes, patterns and portents, but they had no way of knowing that the stars were other suns, that the Milky Way was a galaxy of hundreds of billions of stars, that the universe extended billions of light years in every direction. We are the first generation in human history to have even a rough idea of where we are in the cosmos. We are the first to know with any confidence the age of the universe, its size, its composition, its history. This knowledge is a gift, and it carries with it a responsibility. To use it wisely, to share it generously, and to pass it on to future generations. As we prepare to enter the final stage of our journey, let the immensity of what we have learned settle gently into your awareness. You do not need to hold all the numbers in your head to remember the exact distance to Andromeda or the precise diameter of the observable universe. What matters is not the details, but the perspective, the sense of scale that these numbers evoke. You are small, yes, but you are also part of something vast and beautiful and full of mystery. And in that realization, there is a kind of peace that can carry you through the darkest nights. Now, as we near the end of our journey, let us turn our attention to something both simple and profound: the night sky itself. For all the knowledge we have gained, for all the vast distances we have crossed in our imagination, the night sky remains the same. It is still there, above us, waiting to be seen. And perhaps the greatest gift of our journey is not the facts we have learned, but the way we will see that sky from now on, with new eyes, with a deeper sense of what lies behind each point of light. Tonight, if you have the chance, step outside and look up. Find a place away from streetlights, away from the glow of cities, where the sky is truly dark. Give your eyes time to adjust. Let the pupils widen. Let the rods and cones in your retinas become sensitive to the faint light arriving from across the cosmos. And then simply look. What do you see? Thousands of stars, scattered across the dome of the sky like diamonds on black velvet. Some are bright, some are faint. Some seem to twinkle, their light distorted by turbulence in Earth's atmosphere. Others shine with a steady, unwavering glow, and stretching across the sky, if you are far enough from city lights, you will see a faint band of milky light. The disk of our galaxy seen edge on, the combined glow of hundreds of billions of stars too distant and too faint to be seen individually. Now, with the knowledge you have gained, look again at that band of light. Each point in that luminous band is not a cloud but a star, a sun like our own, perhaps with its own family of planets, its own possibilities for life. The light from those stars has been traveling for hundreds or thousands of years to reach your eyes. Some of those stars may have planets where other beings, if they exist, are looking up at their own skies and wondering about the nature of the universe. And the spaces between those stars, the dark gaps you see, are not empty. They are filled with gas and dust, with the raw material from which new stars and new planets will form, with the scattered remains of stars that lived and died long before our sun was born. Look now at the individual stars. The brightest ones, the ones that catch your eye immediately, are not necessarily the closest. They are the most luminous, the giants and supergiants that outshine their neighbors by factors of thousands or millions. Betelgeuse in the shoulder of Orion is one such star. It is a red supergiant, so large that if it were placed at the center of our solar system, its surface would extend past the orbit of Jupiter. It is also unstable, nearing the end of its life, and someday, perhaps tomorrow, perhaps 100,000 years from now, it will explode as a supernova, outshining everything in the sky for weeks or months. When that happens, the light from its explosion will have been traveling for about 600 years, and we will finally see it. Other bright stars are closer, like Sirius, the brightest star in Earth's night sky. It is only 8.6 light-years away, a neighbor in cosmic terms. It is a binary system with a bright main sequence star and a faint white dwarf companion. The remnant of a star that was once more massive than the Sun, but has since exhausted its nuclear fuel and collapsed to an Earth-sized sphere of degenerate matter. That white dwarf is so dense that a teaspoon of its material would weigh several tons. It is a ghost, a stellar corpse, a reminder that even stars must die. And then there are the faint stars, the ones you can barely see, the ones that require averted vision and patience to detect. Many of these are red dwarfs, small, cool, long-lived stars that burn their fuel slowly and can last for trillions of years. Some of them may have planets in their habitable zones, worlds where the conditions for life might exist. Proxima Centauri, our nearest stellar neighbor, is such a star. It is so faint that it cannot be seen without a telescope, even though it is only 4.24 light-years away. If you were standing on a planet orbiting Proxima, looking back toward our sun, you would see it as a moderately bright star, unremarkable among thousands of others. As you look at the night sky, remember also what you cannot see. You cannot see the planets orbiting other stars, though we now know they are common. You cannot see the black holes, the dark remnants of massive stars scattered throughout the galaxy. You cannot see the dark matter, the invisible substance that outweighs all the visible stars by a factor of 5. You cannot see the cosmic microwave background, the afterglow of the Big Bang, though it fills all of space and bathes everything in a faint, uniform glow. The night sky is a veil, a thin layer of visible light that hides a universe far richer and more complex than our ancestors could have imagined. And yet, for all that we cannot see, what we can see is enough. It is more than enough. It is a window into the cosmos, a reminder of our place in the universe, an invitation to wonder. So tonight, if you can, step outside and look up. Let the stars wash over you. Let their light, some of it ancient beyond comprehension, fall on your skin and enter your eyes. And know that you are part of something vast and beautiful and full of mystery. You are a child of the universe, born of stardust, conscious and aware, capable of marveling at the immensity that contains you. And in that marveling, you are not alone. You are part of a long lineage of humans who have looked up at the night sky and wondered, who have asked the same questions we ask today, who have sought to understand their place in the cosmos. And you are part of a future generation that will continue to ask, to seek, to wonder long after we are gone. As our journey together begins to draw toward its close, let us take a moment to consider something that we have touched upon but not yet fully explored: the relationship between the vastness of the universe and the intimacy of our own experience. For all the immensity we have traversed, for all the billions of light years and billions of years we have contemplated, we end where we began. Here, in this quiet moment, in this room, in this body, in this life. The universe may be vast, but it is experienced only through the small, the personal, the immediate. And perhaps there is a wisdom in that, a lesson that the cosmos itself is trying to teach us. Think about the light that has traveled billions of years to reach us. It has crossed distances so vast that they defy comprehension. It has passed through regions of space where there is nothing but darkness and cold. It has been traveling since long before our planet existed, since long before our sun was born. And finally, after all that time, after all that distance, it arrives here at this moment and interacts with the retina of a human eye, or the mirror of a telescope, or the sensor of a camera. All that journey, all that time for this, for a single moment of contact, a single flash of perception, a single bit of information added to the sum of human knowledge. There is something profoundly moving in this thought. The universe, it seems, is not content to simply exist. It wants to be seen, to be known, to be appreciated. And we, the conscious beings of Earth, are the means by which this happens. Through our eyes, the universe sees itself. Through our minds, the universe knows itself. Through our wonder, the universe marvels at itself. We are not separate from the cosmos. We are its sensory organs, its awareness, its voice. And in this realization, the vastness of the universe becomes not a source of alienation, but a source of connection. Consider, too, the scale of human life against this cosmic backdrop. A human lifetime is, at best, about 100 years. In cosmic terms, this is less than an instant. The universe has been around for 13.8 billion years, and it will continue for trillions more. Our entire species, all of human history, all of our achievements and failures, our art and science, our loves and losses, is contained within a blink of the cosmic eye. And yet, within that brief moment, we have managed to comprehend something of the eternal. We have reached out across billions of light years and touched the edge of the observable. We have looked back in time nearly to the beginning. We have told the story of the cosmos, at least in outline, and we have found our place within it. This is no small thing. It is, in fact, one of the most remarkable achievements of our species. And it is an achievement that belongs to all of us, not just to the scientists and philosophers who have done the work. Because the sense of wonder, the desire to understand, the need to know where we are and what we are, these are not specialized pursuits. They are part of what it means to be human. They are present in every child who looks up at the night sky and asks, "What are those lights?" They are present in every adult who pauses, for just a moment, to watch a sunset or a meteor shower. They are present in you, right now, as you listen to these words and contemplate the immensity we have explored together. So let us carry this wonder with us as we go about our lives. Let it inform how we treat each other, how we treat our planet, how we think about our future. Let it remind us that we are part of something larger than ourselves, that our differences are small compared to what we share, that our time here is precious and brief. The universe is vast, and we are small, but we are here, and that is enough. Now, as we prepare for the final stage of our journey, let us take a slow, deep breath together. Feel the air entering your lungs, filling your body with life. Feel the weight of your body against the surface that supports it. Feel the warmth of your own skin, the gentle rhythm of your heartbeat. These are the most intimate scales of all, the scales of human experience. And they are no less miraculous than the billions of light years we have traversed. For in the end, the universe is not something out there, separate from us. It is something we are made of, something we participate in, something we carry within us. And in that truth, there is a peace that passes all understanding. And so we arrive at the final stage of our journey together, the last few steps before we gently set you down into the embrace of sleep. But before we do, let us take a moment to gather the threads of all we have explored, to weave them into a tapestry that you can carry with you into your dreams and beyond. We have traveled from the intimate scale of our own planet to the farthest reaches of the observable universe. And in doing so, we have encountered a truth that is both simple and profound. The universe is vast beyond comprehension, and we are an intimate part of it. Let us retrace our steps one last time, but lightly now, like a whisper, like a memory. We began on Earth, that blue marble hanging in the darkness, with its oceans and continents, its mountains and valleys, its teeming billions of life forms. We saw how small it is compared to Jupiter, how 1,300 Earths could fit inside that single gas giant. We traveled to the moon, that silent companion, and imagined the distance between them filled with all the other planets of our solar system. We felt the emptiness of space, the vast gulfs that separate world from world. Then we turned toward the sun, that great fiery heart of our system, and learned that it contains 99.86% of all the mass in the solar system. We measured distances in astronomical units, feeling the scale of our cosmic neighborhood. We journeyed to the edge of the sun's influence, to the Oort cloud, that spherical shell of icy bodies nearly a light year from home. And there we paused, standing at the threshold between our system and the galaxy. We learned a new measure then, the light year, and understood that it is not a measure of time but of distance, the distance light travels in a year. We crossed the gulf to Proxima Centauri, our nearest stellar neighbor, 4.24 light-years away. We felt the immensity of that distance, the millions of years it would take to cross it in our imaginary airliner. And we began to understand that space and time are woven together, that to look outward is to look backward. Then we expanded our view to encompass the Milky Way, our galactic home, with its 100,000 light-year diameter and its hundreds of billions of stars. We found our place in it, in the Orion Arm, 26,000 light-years from the center. We saw the galaxy as a vast city of light, and ourselves as residents of its quiet suburbs. And we marveled at the number of stars, more than all the grains of sand on every beach on Earth. We left the Milky Way then and entered the local group, our galactic neighborhood. We visited Andromeda, our great twin spiral, 2.5 million light-years away, approaching us at 110 kilometers per second. We saw the dozens of dwarf galaxies that orbit the larger members, the Magellanic Clouds, the Triangulum Galaxy, and all the others. And we felt the scale of the space between galaxies, the millions of light-years of emptiness. We expanded further into the Virgo supercluster, that vast assembly of galaxy groups and clusters stretching 110 million light-years across. We felt the pull of the Virgo cluster, the gravitational heart of our supercluster, toward which we are all falling. And we began to see the large-scale structure of the universe, the filaments and voids, the cosmic web that connects everything to everything else. Beyond that, we entered Laniakea, the immeasurable heaven, a supercluster of superclusters spanning 520 million light-years. We felt the pull of the great attractor, that hidden concentration of mass toward which we are all drifting. And we understood that even on these immense scales, nothing is still, everything flows, everything participates in the great cosmic dance. Finally, we reached the edge of the observable universe, that sphere 93 billion light-years across, beyond which light has not had time to reach us since the beginning. We contemplated the 200 billion galaxies within that sphere, the trillions of stars, the countless worlds. And we understood that this is only what we can see, that the full universe may be vastly larger, perhaps infinite. And then we began our journey back, descending through all those layers, pausing at each to reflect on what it means. We returned to the night sky, to the familiar stars above, and we saw them with new eyes. We considered the relationship between the cosmic and the personal, the vast and the intimate. And we arrived back here, in this quiet moment, in this room, in this body, in this life. Now, as we prepare to let you go, To release you into the gentle embrace of sleep, let us leave you with a final thought. The universe is vast beyond measure, and we are small. But we are not insignificant. We are the universe's way of knowing itself, its eyes and ears, its consciousness and wonder. In each of us, the cosmos has produced something that can look back at it and marvel. And in that marveling, we are connected to everything that exists, to every star that has ever shone, to every galaxy that has ever spun, to the very origins of space and time. So rest now, knowing that you are part of something vast and beautiful and full of mystery. Rest knowing that the stars are still there, shining their ancient light down upon you. Rest knowing that you are loved, that you are valued, that you are enough. And when you wake, carry this knowledge with you into the new day, that you are a child of the universe, born of stardust, conscious and aware, and that your presence here, in this moment, is a gift beyond measure. And now, as the final stars of our journey begin to fade gently from view, let us slow everything down. Let the vast distances we have traveled collapse softly, like a universe folding in on itself, until only this moment remains. The billions of light years, the trillions of stars, the countless galaxies. Let them all recede now, not into forgetfulness, but into a kind of background hum, a cosmic lullaby that cradles you without demanding anything in return. Feel how heavy your limbs have become. Feel the gentle pull of gravity, the same gravity that holds planets in their orbits and galaxies in their clusters, now holding you safely here, in this place, in this moment. Your bed is your spacecraft, your pillow your command module, your blanket the warm embrace of atmosphere that shields you from the cold of space. You have traveled further tonight than any human has ever traveled, and now it is time to rest. Let your breath slow just a little, in and out, in and out. With each exhale, feel the tension leave your body, starting at the crown of your head and flowing downward, like sand through an hourglass. Release your jaw, your neck, your shoulders. Let your arms sink deeper into the surface beneath you. Let your legs grow heavy, your feet warm and still. You are here, you are safe, you are exactly where you need to be. The universe will continue its slow dance without you for a few hours. The stars will overhead, the galaxies will spin, the cosmic web will stretch and shift, but none of it requires your attention right now. Right now, all that is required of you is to rest, to let go, to drift. The universe has been patient for 13.8 billion years. It can wait a few more hours for you to wake. Think of the atoms that make up your body: carbon, oxygen, hydrogen, nitrogen, traces of others, all of them forged in stars that lived and died long before our sun was born. Those atoms have been waiting billions of years to be part of this moment, to be part of you, to experience what it feels like to be warm, to be loved, to be alive. And now, as you drift towards sleep, those atoms will rest with you, will slow their dance, will dream the dreams of matter that has briefly become conscious. There is no need to hold on to any thought, any image, any number. Let them all float away, like balloons released into a dark sky. If the image of a galaxy comes to mind, let it drift past without clinging. If the memory of a particular star arises, let it fade. There is nothing to remember, nothing to solve, nothing to figure out. There is only this: the slow rhythm of your breath, the gentle weight of your body, the soft darkness behind your eyelids. You have done enough today. You have thought enough, felt enough, experienced enough. Now it is time to let the universe take over, to let the same forces that spin galaxies and ignite stars carry you gently into the realm of sleep. It is a safe place, a soft place, a place where you are held and protected. So rest now, dear traveler. Rest deeply, rest peacefully, rest without dreams if that is what you need, or with dreams as gentle as starlight if that is what comes. You have earned this rest. You have journeyed to the edge of the observable universe and back, and now you are home, safe in your bed, wrapped in the quiet of the night. And as you slip beneath the surface of sleep, know this: the universe will be here when you wake, still vast, still beautiful, still full of mystery. But for now, it releases you. For now, it asks only that you rest. Sweet dreams.